Hello everyone, very good evening. So I'm sure over the weekend you would have got some time to practice the first chapter, past year questions or some of the important models of questions, right? Because we completed the first part. And in the NCERT, we have this electrostatics split into two chapters. First chapter already we cover electric field concept and Coulomb's law regarding the force. Second part of the chapter is about electric potential energy and capacitors. Okay, so we are going to start with the second part of this electrostatics. So mainly if you look at it, two questions in the chapter. One question will be from that electrostatics field and force concept, and second question will be typically from the potential and the capacitors. Okay, so first we'll talk about the electrostatic potential energy. And potential concept we should understand the idea of what is potential energy. And potential energy will define this electric potential concept. Electric potential is going to come from where? It is going to come from the idea of the potential energy. Okay, so here first electrostatic potential energy, and we should understand what is this potential energy concept. First of all, it will come in the mechanics. Remember, for the conservative forces we use the potential energy term. Potential energy term we use only for what? Conservative force. Conservative force and examples we have gravitational force, that is a conservative force, and the madri electrostatic force. So we'll see electrostatic force is also what? Conservative force. For the conservative forces, and we will define the concept of potential energy. How that the potential energy concept will be defined for the conservative forces. First, what is a conservative force? Conservative force and if you have forces, right, we look at the work done by the force. All forces will have the work done, right? If the work done by the force is independent of the path, if the work done by the force is independent of the path, the total work done in a closed loop or closed path is zero. Then such forces are going to be called as what? Conservative forces. If you look at the work done, it will be independent of the path. Point 1 and point 2 whether you go in this path, normally we'll say work will depend upon the path, right? But in the conservative force work will not depend upon the path. It only depends upon initial point and the final point. Okay, so we are going in the path A, or going the path B, or going some random path C. We are going to have the same work done. Such type of forces we call them as what? Conservative forces. Okay, that's significance. If you look at a closed loop or a closed path, work done in the closed path will be what? Zero for the conservative force. Let's look at first of all gravitation force. Okay, so we have an object of mass m. Point 1 we are taking it to a height h. First of all, point 1 we are taking it to point 2. Okay, now what is the gravitational force acting on that object? Mg dana, it will be downwards. When we take it from point 1 to 2, displacement upwards, gravitational force is downwards. So what is the angle between them? 180 dana. So work done by the gravitational force will be what? Force into displacement into cos theta. Okay, so when the cos 180 means -1. So what is this? minus mgh. This is the work done by that gravitational force when we take it from 1 to 2. திருப்பி அந்த 2ல இருந்து if you bring it to 1, 2ல இருந்து அப்படியே we bring it to 1. So இது என்ன ஆயிட்டு இருக்கா, this is becoming a closed loop, right? ஏன்னா 1ல இருந்து ஸ்டார்ட் பண்ணி we are going to 2, அதுக்கப்புறம் திருப்பி we will come back to 1. இது என்னது, closed loop. So 2ல இருந்து 1 வரும்போது what is it, gravitational force ஓட direction change ஆகாது, அது அப்படியே downwards தான் இருக்கும். பட் இங்க பாருங்க, when you are coming from 2 to 1, now the displacement is what, same h, value மாறாது, value is h only, but direction எப்படி, downwards. So both the gravitational force and the displacement ரெண்டுத்துக்கு என்ன ஒரே direction தானா, both are downwards. இப்போ பாருங்க, work done by the gravitational force when you bring it from 2 ல இருந்து 1, அது என்னது, force into displacement into cos 0 வரும். எதனால cos 0, because both are in the same direction தானா, parallel. weight கீழ தான் இருக்கா, I mean weight is pointing downwards, அந்த மாதிரி the displacement is also downwards. அதனால the angle between them is what, 0. இங்க பாருங்க, cos 0 எவ்வளவு, 1, which means mgh. So total work ன்னு சொன்னது, the work that is done when we go from 1 to 2 plus the work done by the gravitational force when you come back, ரெண்டுத்தையும் ஆட் பண்ணி பாருங்க, minus mgh plus mgh எவ்வளவு, 0. means if you look at the gravitational force, ஒரு closed loop எடுத்தா, then what is the work done by the gravitational force, என்னது, it is becoming as what, 0. அதனால we will consider the gravitational force as what, conservative force. அதனால what do we consider the gravitational force as, conservative force. ஓகேவா, ஏன் நம்ம இந்த particular aspect நம்ம டிஸ்கஸ் பண்ணோம்னா, because we need to understand what is the basis, எந்த basis வச்சு நம்ம இதை classify பண்றோம், like you know on what basis we are classifying the forces as conservative இல்லனா non conservative னு சொல்லிட்டு. okay, conservative force இல்லனா the other type of forces will be called as what, non conservative. இப்போ எது conservative இல்லையோ மத்ததெல்லாம் it will be what, non conservative தானா, like இப்போ friction ஆகட்டும் or all the other forces will be called as what, non conservative forces. okay, so இப்போ இந்த electrostatic force பத்தி பார்க்கலாம். say ஒரு q1 சார்ஜிங் இருந்து வெச்சுக்கோங்க, q2. for example we will take like charges. the q1 on nature, q2 nature, both are what, same. okay, இப்போ பாருங்க, let us say the distance between them or a ன்னு வெச்சுக்கோங்க, the separation between them. okay, so இங்கல இருந்து by the way what is the force acting on the charge q2, q2 க்கு மேல what will be the electrostatic force acting on it, repulsive force தானா, அது என்னது, k q1 q2 by a square, repulsive. இங்கல இருந்து we will just move this q2 by a small displacement. ஏன் ஸ்மால் டிஸ்பிளேஸ்மென்ட் தெரியுமா, பிகாஸ் நம்ம லார்ஜ் டிஸ்பிளேஸ்மென்ட் கொடுத்தா ஃபோர்ஸோட எக்ஸ்பிரஷனே சேஞ்ச் ஆகும், அதனால we are giving a small displacement. இங்க பாருங்க, force எந்த டைரக்ஷன்ல இருக்கு, repulsive force towards the right side, அந்த மாதிரி நம்ம கொடுத்த displacement also towards the right side. so that small work done, இது நம்ம path 1 ன்னு சொல்லலாம். இந்த ரைட் சைடு இருக்கும்போது it's what, path 1. small work done is what, force other direction இப்படி right side, அந்த மாதிரி displacement also right side. so f into dx into cos 0 வரும். what is it, k q1 q2 by a square into dx. ஓகேவா, அதுக்கப்புறம் என்ன தெரியுமா, we will make it a closed loop. எப்படி நம்ம closed loop பண்ண முடியும், அங்கல இருந்து we will just bring it back, அந்த டிஸ்பிளேஸ்மென்ட் அப்படியே ரிவர்சேஷன்ல கொடுத்தா it will come back to the original point, right? பட் இப்படி நம்ம எடுக்கும்போது, இப்படி நம்ம பேக் சைடு நம்ம எடுத்துட்டு வரும்போது வேணா we see that the force will be towards the right side. எப்போ அதுதானா, the electrostatic force will be what, repulsive force, it will be towards the right side. but displacement எப்படி, it is towards the left side. so in that second part work will be what, f into dx into cos 180 வரும். எதனால cos 180, இங்க நம்ம கொடுத்த displacement dx தான், but it is in the opposite direction to the force, அதனால we will have what, cos 180. so பாருங்க, cos 180 என்னது, -1 தானா, which is what, minus k q1 q2 by a square into dx. Total இது ஒரு closed loop மாதிரி தானா, கொஞ்சம் முன்னாடி எடுத்துட்டு போயிட்டு திருப்பி we are bringing it back, closed loop. So what is the work done in this closed loop? And the closed loop குள்ள what is the work done? இந்த ரெண்டு work values நம்ம அப்படியே add பண்ணணும். add பண்ண என்ன வரும்? plus minus cancel ஆடும், which is what? 0. means what? closed loop. நம்ம எடுத்த closed loopல what are we getting? The work done by the electrostatic force தானா? Work done by the electrostatic force is what? 0. அதனால we will consider the electrostatic force also as what? conservative force. நீங்க friction எடுத்து செக் பண்ணி பாருங்க. if you are forming a closed loop, நீங்க closed loop form பண்ணா with friction, right, we will not get total work done in the closed loop 0. அதுல வராது. if you take a closed loop by involving friction force, right, அதுல என்ன தெரியுமா, you will not get the total work done as 0. நீங்க செக் பண்ணி பார்க்கலாம். like say for example இங்க பாருங்க, let us say இது ஒரு ஆப்ஜெக்ட் னு வெச்சுக்கோங்க. okay, so there is an horizontal table மேல we are keeping the object, weight and normal reaction. so vertically displacement கிடையாது, which means what? normal reaction ஓட value is equal to mg. okay, நம்ம இப்படி ஒரு displacement x கொடுத்தா displacement is towards the right side, அதனால frictional force will be acting towards the left. friction force value என்ன? there is a movement, right, so it will be what? kinetic friction, mu into normal reaction. அது என்னது? mu into mg. ஓகேவா? இங்க பாருங்க, the first part இங்கல இருந்து அங்க எடுத்து அங்க ஷிஃப்ட் பண்ணும்போது what is the displacement? it is towards the right side, but friction force எப்படி? friction force is towards the left side. so work done in that path 1 will be what? frictional force into displacement into cos 180 varum, which is what? mu mg into x into minus 1. okay va? so what is it? minus mu mgx. so work done in that path 1. okay, அப்படியே நம்ம திருப்பி அந்த original position எடுத்துட்டு வந்தா what you are going to have? we have to give it the same amount of displacement but towards the left side. இங்க பாருங்க, the object is already here. when we are moving it in the left side direction, இப்போ friction எப்படி act ஆகும்? நம்ம left side movement இருந்தா then friction acting will be opposite. always friction will be opposing the relative motion தானா? so இப்போ நம்ம left side move பண்ணா friction will be acting towards the right side. so இங்க பாருங்க, for that path 2 again work will be what? frictional force into இங்க என்ன? the displacement, same value x. what is the angle between the displacement friction? 180. so mu mg into x into minus 1. திருப்பியும் minus mu mgx தான். so நம்ம giving a displacement x, திருப்பி we are bringing it back. the closed loop தானே? இங்க பாருங்க, this is a closed loop. but closed loop குள்ள what is the work done? w1 plus w2. நீங்க ஆட் பண்ணி பாருங்க, w1 plus w2, that is not going to be equal to 0. அதனால frictional force, right, will not be a conservative force. don't think that எல்லா forcesக்கும் இப்படி தான் வரும்னு சொல்லிட்டு. so in a closed loop work will be 0 only for what? conservative forces. அது examples என்னன்னா gravitational force, electrostatic force, அந்த மாதிரி spring force, all these are what? examples of the conservative forces. ஓகேவா? for the conservative forces we use the potential energy term. okay, அது எங்கல இருந்து வரும் தெரியுமா? using the work energy theorem. so work energy theorem ஓட basic statement என்ன? if you have any object, the work done by all the forces, the object க்கு மேல there are many forces acting on that object வெச்சுக்கோங்க, then work done by all the forces is equal to change in kinetic energy of the object. என்னது? the work energy theorem. okay, so what is the work energy theorem? basic statement: if you have any object, work done by all forces on that object is equal to what? change in kinetic energy of the object. okay, so this is the work energy theorem basic statement. but conservative forces பாத்தீங்கன்னா work done will not depend upon the path. work done path மேல depend ஆகாது. it only depends upon what is the initial point and the final point. அதனால என்ன, instead of calculating the work done by the conservative forces each and every time, ஒரு தடவை நம்ம calculate பண்ணலாமே, what we will do is we will try to adjust this in the form of a energy term. அது எப்படின்னு சொல்லிட்டு பார்க்கலாம். So work done by all the forces சொன்னா என்னது, இதுல we will have conservative forces, அந்த மாதிரி non conservative forces. ஓகேவா? So work done by all the forces means what? Work done by the conservative forces plus work done by the non conservative forces is equal to what? Change in kinetic energy. இப்போ இப்படியே நம்ம அந்த work done by the conservative forces ரைட் சைடு எடுத்து போங்க. It will be what? Left sideல வெறும் work done by the non conservative forces will be equal to what? Change in kinetic energy minus work done by the conservative forces. இப்படி வரும். This is the modified statement. என்னது? This is the modified form of work energy theorem. The work energy theorem is a modified formula. Okay. So இப்போ இதுல இருந்து என்ன தெரியுமா? The potential energy for a conservative force is defined like this. Each and every time நம்ம இந்த work done by the conservative forces calculate பண்ண தேவையில்ல. அதுக்காக we are introducing a new energy term for the object. Okay. What is the new energy term going to be called as? Potential energy. எப்படி? The relation is negative of work done by the conservative force. In the term அப்படியே negative of work done by the conservative force is going to be replaced with what? The change in potential energy of the object. And the object மேல conservative forces will do some work, right? Negative of work done by the conservative forces. அது அப்படியே நம்ம replace பண்ண போறோம். எது வெச்சு? Change in potential energy. இப்போ பாருங்க, in the negative of work done by the conservative forces பதிலா we are going to keep what? Change in potential energy. So this is our final modified work energy theorem. என்னது பாருங்க, work done by the non conservative forces மட்டும் will be equal to what? Change in kinetic energy plus change in potential energy. இதுதான் நம்ம frequent-ஆ யூஸ் பண்ணுவோம். This is what is the work energy theorem formula that we use normally, right? Work done by the non conservative forces, external forces, is equal to what? Change in kinetic energy plus change in potential energy. Potential energy term நம்ம எதுக்கு define பண்றது? Only for the conservative forces, like in the gravitational force ஆகட்டும் or the electrostatic. இந்த மாதிரி forces என்ன தெரியுமா? We will define something called as a potential energy. So திருப்பி நம்ம அந்த work done by these forces நம்ம calculate பண்ண தேவையில்லை. ஏன்னா this is getting adjusted in the potential energy formula. It's getting adjusted in the potential energy formula. So when we use the gravitational potential energy, right? அப்போ நம்ம திருப்பி அந்த work done by the gravitational force calculate பண்ண தேவையில்லை. Already it is getting adjusted for the potential energy termல அது வருது. Okay. So the new work energy theorem எப்படி? What is the new work energy form statement? Work done by the other external forces and non-conservative forces is equal to change in kinetic energy plus change in potential energy. But இந்த formula யூஸ் பண்றதுக்கு என்ன தெரியுமா? We need to know what is the potential energy. இப்போ gravitational potential energy ன்னா அதுக்கு ஒரு எக்ஸ்பிரஷன் இருக்கும். அந்த மாதிரி electrostatic potential energy ன்னா அதுக்கு ஒரு எக்ஸ்பிரஷன் இருக்கும். So we should know what is the formula or the expression for calculating this potential energy. Okay, so அதுதான் நம்ம பார்க்க போறோம். So we are going to look at how do we calculate. So gravitation இங்க நம்ம கவர் பண்றது கிடையாது. We will cover it in the gravitation chapter. But இங்க என்ன தெரியுமா? We will see how to calculate the potential energy for a combination of two charges. ஒரு ரெண்டு சார்ஜோட காம்பினேஷன் நம்ம கிட்ட வெச்சோம். Then how to find the potential energy of the combination. So small derivation நம்ம பண்ண போறோம். பாருங்க. Let us say ஒரு charge Q1 அந்த மாதிரி இங்க ஒரு charge Q2 separated by a distance a. இதான the initial arrangement. ஓகேவா? For the simplicity sake Q1 and Q2 நம்ம like charges எடுக்கிறோம். Means what? Q2 பாத்தீங்கன்னா it will be repelled அப்படியே. So இங்கல இருந்து let us say the Q2 is moved until it reaches distance b. Initially என்ன both are at a separation a. அங்கல இருந்து Q1 அப்படியே நம்ம ஸ்டேஷனரியா வச்சிட்டு we are trying to move the Q2 charge. So distance a ல இருந்து finally it is going up to distance b. Okay. Now in the movement we need to find what is the work done by this electrostatic force. Okay. So இப்போ பாருங்க, electrostatic force is a variable force. Why is a variable force? Because depends on the distance. And the rendu charge nadula, what is the distance, right? Ipo nama q2 shift panna and rendu nadula, what is the distance? It is going to keep on changing dana, which means what? If the distance between q2 and q1 is changing, the force between them also is going to change, which means here we have a variable force, a constant force kadayadu, variable force. Okay, adanal enna theriyuma, we will consider ஒரு general position. For example, ஒரு distance x ல இருந்து வெச்சுக்கோங்க, that is the general position. Okay, at a general position x, அங்கிருந்து we are giving a displacement dx. Okay, அங்கிருந்து we are giving a displacement dx for a small displacement, dx. இங்க பாருங்க, force எப்படி ஆக்ட் ஆகும்? ரைட் சைடு தானா, which means electrostatic force and displacement ஒரே direction. The small work done by that electrostatic force என்ன? K q1 q2 by x square, இதுதான force formula, into dx. இப்போ நமக்கு என்ன வேணும்? We want to know what is the total work done when we are moving from this point to this point. அப்ப நம்ம என்ன பண்ணணும்? We have to integrate this between the limits. X oda value எங்கல இருந்து? A to B. So K q1 q2 by x square into dx. அந்த expression நம்ம அப்படியே integrate பண்ணணும் from the initial limit A to B. So அதில இருந்து we are going to get what is the total work done. நம்ம A ல இருந்து மூவ் பண்ணும்போது what is the total work done by the electrostatic force. இங்க பாருங்க, K q1 q2 is a constant, அது அப்படியே வெளியே வரும். A to B 1 by x square ன்னு சொன்னது x power minus 2 தானா? So x power minus 2 dx. So integration நமக்கு ஒரு சில standard results இருக்கு. என்னது? If you have integral x power n dx, அதோட result என்னது? x power n plus 1 by n plus 1. So இது எப்படி இருக்கா? x power n dx தானா? n is minus 2. So K q1 q2 x power n plus 1 தானா? n plus 1 means what? X power minus 2 plus 1 means minus 1. Divide by minus 1. இது என்ன தெரியுமா? நம்ம லிமிட் சப்ஸ்டிட்யூட் பண்ணணும். Initial limit is A, final limit is B. Okay. So totally பாத்தீங்கன்னா what is it? K q1 q2, அதுக்கப்புறம் x power minus 1 சொன்னது 1 by x தானா? minus இருக்கா? So minus 1 by x. இதுல நம்ம லிமிட் சப்ஸ்டிட்யூட் பண்ணணும். ஃபைனல் லிமிட் என்ன? B, இனிஷியல் லிமிட் என்ன? A. ஓகே, சோ இப்போ பாருங்க, K q1 q2 அப்படியே வெளியே இருக்கும். இந்த டேர்ம் மட்டும் பாருங்க, லிமிட்ஸ் எப்படி சப்ஸ்டிட்யூட் பண்றதுன்னு சொல்லிட்டு, minus 1 by B minus of minus 1 by A. இந்த மைனஸ் மைனஸ் கேன்சல் ஆயிட்டு பிளஸ் ஆகும். ஸோ என்னது? 1 by A minus 1 by B. ஸோ டோட்டலி பாருங்க, வாட் இஸ் திஸ் W வேல்யூ? K q1 q2 into 1 by A minus 1 by B. இதுதான் ஒர்க் டன். பாருங்க, ஜஸ்ட் அந்த நம்ம இன்டிகிரேஷன் ஃபைனல் ஸ்டெப் மட்டும் நம்ம கொஞ்சம் கேர்ஃபுல்லா இருக்கணும். So work done formula என்ன? W is equal to what? K q1 q2 into 1 by A minus 1 by B. இதுதான் work done ஓட expression. When the charge is moving from A to B. இதுல என்ன தெரியுமா? Initially நம்ம அந்த assumption ஒன்னு பண்ணிருக்கோம். என்னது? We are taking the like charges ன்னு சொல்லிட்டு. இப்போ say for example the charges are not like charges. Then what is going to happen? In the formula q1 q2 substitute பண்ணும்போது we will have to substitute it along with the sign. That will take care of. Along with the sign நம்ம substitute பண்ணா both are like charges வெச்சுக்கோங்க. அதுல இருந்து we will see that this product will be positive. அப்படி இல்லாம let's say for example one is positive one is negative ன்னா அந்த product ஓட value will be what? Negative. So the sign values கூட நம்ம substitute பண்ணா that is going to take care of the work. இங்க பாருங்க, work done அதுக்கு expression என்ன? K q1 q2 into 1 by A minus 1 by B. Okay. What is the potential energy or definition? எப்படி நம்ம அந்த potential energy define பண்றது? Negative of work done by the conservative force is equal to change in potential energy. இப்படிதானா? Change in potential energy என்னது? Final potential energy minus initial potential energy. Finally is when the distance is b between them. Initially is when the distance is a. So negative of work done by the conservative force. இதுக்கு நம்ம negative பண்ணணும். Negative of W means what? Minus k q1 q2 into 1 by a minus 1 by b is equal to what? Change in the potential energy. Potential energy when the charges are at a separation b minus potential energy when the charges are at a separation a. Okay, wow. So what is the concept? Potential energy when the charges are at a separation b minus potential energy when the charges are at a separation a. Okay, இங்கல இருந்து நீங்க simplify பண்ணலாம். மைனஸ் அப்படியே நம்ம உள்ள எடுத்துட்டு போனா what is it going to be? K q1 q2 into 1 by b minus 1 by a will come. This is what? Potential energy at b minus potential energy at a. So நம்ம normally பாத்தீங்கன்னா we are going to get only the potential energy difference value தான் நமக்கு வரும். Absolute potential energy value நமக்கு வராது. For any conservative force, right? Potential energy நம்ம அந்த definitionல இருந்து என்ன வரும்? We are going to get only the difference in potential energy தான் வரும் தவிர we are not going to get the absolute value of the potential energy. But when we say potential energy of two masses, ஞாபகம் இருக்கா gravitation chapter என்ன? We will say the potential energy of the two masses is minus g m1 m2 by r. அப்படியே we will just give the formula, right? இந்த formula எப்படி வரும்? For potential energy we use a reference state. So இங்க பாருங்க, so இதுதான் expression. What is the potential and potential energy difference expression என்ன? K q1 q2 into 1 by b minus 1 by a. That is what? Potential energy when the charges are at a separation b minus potential energy when the charges are at a separation a. Okay, so இதுதான் நமக்கு வர formula. இங்கல இருந்து என்ன தெரியுமா? When the charges are infinitely separated, means they are very far away, we assume that the potential energy of the charges when they are at a very large separation is zero. ஏன்னா when the charges are very very far away, right? ஒரு charge ஓட influence இன்னொரு charge மேல இருக்காது. So அதனால we will assume what? The potential energy, the interaction இருக்காது. So அதனால we will assume that the potential energy is what? Zero. So this is the reference. இது என்னது? Reference. Like நம்ம எப்படி gravitationல we will take the potential energy on the surface of the earth to be zero. அதுல இருந்து if you go to a height h means it will be what? mgh. Okay, அந்த மாதிரி இங்க என்ன? We will take the potential energy when they are at a large separation is what? Zero. That is the reference state. இப்போ நம்ம கிட்ட இருக்க ஃபார்முலா என்ன? K q1 q2 into 1 by b minus 1 by a is equal to what? Potential energy when the separation is b minus potential energy when the separation is a. இதுல என்ன தெரியுமா? We will take b to be infinity. b நீங்க infinity எடுத்தா what is it? 1 by infinity means 0 தானா? So பாருங்க left hand side என்ன இருக்கும்? K q1 q2 into minus 1 by a is equal to potential energy at infinite distance minus potential energy at a. இதுல என்ன தெரியுமா? அப்படியே நம்ம rearrange பண்ணணும். இது இந்த பக்கம் எடுத்துட்டு வந்தா it will become what? Plus potential energy when the two charges are at separation a is equal to what? Minus right side போனா it will become what? Positive. K q1 q2 by a plus potential energy at infinite distance. இதுதான் நமக்கு வர base formula. என்னது? Potential energy of the two charges when they are at a separation a, அதோட வேல்யூ என்ன? K q1 q2 by a plus potential energy of the same two charges when they are at infinite separation. நிறைய பேர் என்ன தெரியுமா? இந்த ரிசல்ட் அப்படியே they will try to overlook it, but இதை நம்ம overlook பண்ண முடியாது because there is always a chance for us to get straight questions from this. So potential energy என்ன தெரியுமா? It is always going to depend upon what is the reference. இப்போ நம்ம எடுக்க reference என்ன? When the charges are at infinite distance, we are assuming that the potential energy at infinite distance is what? Zero. So in the formula you take this as zero. நீங்க zero எடுத்தா என்ன வரும்? Potential energy of the two charges separated by a distance a, what is it? K q1 q2 by a. இது எப்படி வருது? When we assume that the two charges when they are infinitely separated their potential energy is 0. அந்த reference நம்ம assume பண்ணா அதிலிருந்து we'll get the absolute இதை நம்ம absolute potential energy ன்னு சொல்லுவோம். Then the absolute potential energy means we are clearly telling that okay, when the two charges are at a separation A, and the charge combination of the potential energy என்னது k q1 q2 by A. Okay, so but இதுக்கு we are taking a reference என்னது the infinite distance is the reference state. Okay வா, so இந்த formula மட்டும் நம்ம கரெக்ட்டா ஞாபகம் வச்சுக்கணும். ஏன்னா இதிலிருந்து we can expect some reasoning questions, like you know I will show you one question பாருங்க. so இதிலிருந்து வர final formula என்ன, two charges are separated by distance A, then the potential energy of the pair, இங்க என்ன தெரியுமா, potential energy ஒரு சார்ஜுக்கு நம்ம டிஃபைன் பண்றது கிடையாது, it is a combination of the two charges. For a pair of charges we will give the potential energy formula. What is the value for that, k q1 q2 by A. இதில் நீங்க கொஞ்சம் observe பண்ணா என்ன தெரியும், if the two charges are like charges, the q1 q2 same type of charge வச்சுக்கோங்க, what is it that you are going to get, the potential energy of that combination is going to be what, positive ஆகும். Okay, அப்படி இல்லாம if the two charges are unlike charges இருந்தா then what is it, the potential energy is going to be negative. Okay, so இதிலிருந்து there is a very important point, if the two charges are like charges then potential energy is what, positive. இங்க மட்டும் கிடையாது, but wherever, right, when potential energy of a system is positive, okay, அதிலிருந்து ஒரு conclusion என்னன்னா, that system, right, is going to be a repulsive system. நமக்கு இங்க இருக்கிற மாதிரி, like if you have two like charges means what, they will be repelling. How do we understand this from the potential energy point, or given arrangement or given system அதோட potential energy positive ன்னு வெச்சுக்கோங்க, then it means what, it is a repelling system. If the potential energy is negative, like we have a positive charge and negative charge, potential energy will be what, negative dana, and what these two charges will do, they will try to attract. So potential energy of charges is negative means they are attracting, means anywhere we have the potential energy of that system is negative means what, it represents attractive system. இது இங்க ஒரு significance. இந்த potential energy value பார்த்துட்டு we can tell about what kind of a system it is, either repulsive system இல்லனா attractive system ஆன்னு சொல்லிட்டு. Okay, so டக்குனு they will just give value. Okay, they will say that the potential energy of a charge arrangement is plus 20 microjoules. அதிலிருந்து they can give us options, you know, what kind of system it is it a repulsive, attractive அப்படி. So on the positive பார்த்த உடனே what is the conclusion, it will be repulsive system. Negative இருந்தா it will be what, attractive system. Okay வா, now just look at this question. No, நான் சொன்ன தெரியுமா, அந்த reference change பண்ணா என்ன ஆகும், like when you change the reference, potential energy term is dependent upon the reference base பண்ணி தான் potential energy ஓட value வரும். இங்க பாருங்க, potential energy of two charges arrangement, இந்த ரெண்டு சார்ஜ் ஓட arrangement என்னது, minus 26 joules. Okay, if the potential energy at infinite separation, எங்க potential energy at infinite separation is taken as 4 joules instead of 0, என்ன சொல்றாங்க, 0 க்கு பதிலா they are saying take it as 4 joules, what will be the new potential energy? Okay, இங்க பாருங்க, what is the normal, if you take the potential energy at infinity as 0, what is the formula for the potential energy of the two charges, இதுதானா, k q1 q2 by A, அதோட வேல்யூ என்ன கொடுத்திருக்காங்க, minus 26 joules. Okay, but what is the actual potential energy, it is what, k q1 q2 by, is the actual formula, இது நமக்கு ஞாபகம் வெச்சுக்கணும். What is it, this is the actual formula, right, k q1 q2 by A plus the potential energy value at infinity, this is the reference we take. Is that a reference, normally என்ன நம்ம எடுக்க போறோம், we take the reference potential energy at infinity 0, அதனால அப்படியே the k q1 q2 by value is what, that is our potential energy minus 26. இங்க என்ன சொல்றாங்க, if the potential energy at infinite separation is taken as 4 joules instead of 0, 0 க்கு பதிலா they are saying take it as 4 substitute பண்ண என்ன வரும், இங்க பாருங்க, k q1 q2 by A எவ்வளவு, minus 26 joules plus 4 joules. இதானது minus 22 joules. இதுதான் new potential energy. நம்ம reference change பண்ண என்ன ஆகும்? The initial normal potential energy 26 minus 26 joules னு வெச்சுக்கோங்க. They say at infinite separation potential energy is changed from 0 to 4. என்ன பண்ணணும்? அப்படியே அந்த 4 ஆட் பண்ணணும், அவ்வளவுதான். ஏன்னா ஃபார்முலா என்னது? The potential energy, total potential energy at any location is equal to what? K Q1 Q2 by A. இதுதான் நம்ம நார்மலா எடுக்கிறோம். K Q1 Q2 by A plus reference. Reference is taken as normally 0. But if they say reference is changed, எவ்வளவு அந்த சேஞ்ச் பண்ணிருக்காங்க அந்த வேல்யூ மட்டும் நம்ம அப்படியே ஆட் பண்ணணும், அவ்வளவுதான். So பாருங்க, what is the new potential energy of the two charges? It will be what? Original என்ன இருக்கு minus 26 plus அப்படியே அந்த P infinity ஓட வேல்யூ நம்ம ஆட் பண்ணணும், அவ்வளவுதான். Okay, so this formula is an important one. என்ன? Because they have not touched upon this area. Even in a past year papers la பாத்தீங்கன்னா this is a very basic concept, but they have not given questions on changing this potential energy at infinite separation. Maybe in future we might be able to expect some questions. அதுக்கு நம்ம ரெடியா இருக்கணும். Okay, now we will go to potential energy of a system of charges. இப்போ நம்ம என்ன பண்றது? We were looking at potential energy of a pair. We have two charges, அது ஒரு pair, right? For a pair we have potential energy. If you have system of charges சொன்னா we have maybe 3 charges, maybe 4 charges, maybe 5 charges, like we have a system of charges. How do we calculate the potential energy term? எப்படி தெரியுமா? For each pair one potential energy term will come. எப்படி? I mean, no, so just take for example in the Q4 Q5 இல்லன்னு வெச்சுக்கோங்க, வெறும் இந்த Q1 Q2 Q3 மட்டும். Okay, we'll have potential energy for the pair Q1 and Q2. We'll have potential energy for the pair Q1 and Q3. அந்த மாதிரி we'll have potential energy for the pair Q2 and Q3. அவ்வளவுதான். Totally how many pairs are going to come? 3 pairs and hence 3 potential energy terms. Okay, இப்போ இங்க பாருங்க, let us say for example அப்படி நம்ம ஆட் பண்ணணும். ஏன்னா potential energy is what? Scalar தானா? If you say potential energy of the system of charges means what? Potential energy for the Q1 and Q2 plus potential energy for the Q2 and Q3 plus potential energy for the Q1 and Q3. அவ்வளவுதான். இங்க பாருங்க, if you have 4 charges, how many pairs we can form தெரியுமா? If you have 4 charges we can actually form 6 pairs. என்னது பாருங்க, Q1 Q2 Q1 Q3 Q1 Q4 இதெல்லாம் என்ன? by using Q1. அதுக்கப்புறம் Q2 Q3 Q2 Q4. திருப்பி நம்ம அந்த Q2 Q1 கவுண்ட் பண்ண போறது கிடையாது, ஏன்னா ஆல்ரெடி இட் இஸ் கவுண்டட். பாருங்க, அதுக்கப்புறம் Q3 Q4 எத்தனை பேர்ஸ் வரும்? 6 பேர்ஸ் வரும். if you have 4 charges, right? இதுக்கு ஒரு ஷார்ட்கட் ஃபார்முலா என்ன தெரியுமா? if you have n number of charges, like mathematics நம்ம யூஸ் பண்ண மாதிரி, we have to take a combination of 2 charges தானா? how many combinations we can form? that is mathematically given by the function nc2. nc2 ன்னு சொன்னா what is it? n into n minus 1 by 2. so இத்தனை pairs form ஆகும். like in NEET we can expect some straight questions on this also. எப்படி? like they can say there are 25 charges in a system, how many potential energy terms will come? அப்படி கேட்டா what we are going to do? 25 charges, right? means what? n is equal to 25. so how many potential energy terms will come? whatever the number of pairs we can take, those many, because for each pair we have a potential energy term dana, which means what? if you are having 25 charges, for 25 charges how many potential energy terms will come? அப்படி they can ask questions. so what will be the answer? 25 into 25 minus 1 by 2. what is the number of potential energy pairs? it will be what? n into n minus 1 by 2. we can also write it like what? nc2. okay, 3 charges are there means அதுல இருந்து we will get 3 pairs. 4 charges are there வெச்சுக்கோங்க, we are not going to get 4 pairs. எத்தனை pairs வரும்? 6 pairs வரும். நம்ம இங்க பார்க்குற மாதிரி. Okay. If you are having n number of charges, generalize பண்ணும்போது என்ன n number of charges that means we can take how many combinations of 2 at a time? எத்தனை எடுக்கலாம்? We can take a combinations of how many? nc2 number of combinations can be done. nc2 means what? n into n minus 1 divided by 2. அத்தனை potential energy pairs வரும். Okay. அந்த எல்லா potential energy values நம்ம அப்படியே ஆட் பண்ணலாம் அவ்வளவுதான். ஏன்னா potential energy is a scalar, right? If you add all of them means அதிலிருந்து we will get what is the total potential energy of that system of charges. Okay. So இங்க பாருங்க 3 charges q minus 2q and 3q are kept at the corners of an equilateral triangle side length L. What is the potential energy of the system of charges? நீங்க calculate பண்ணி சொல்லலாம். What is it? Just அப்படியே நீங்க represent பண்ணி பாருங்க. So we have 3 charges. என்னது q, அதுக்கப்புறம் minus 2q, அதுக்கப்புறம் 3q. Okay. They are kept at the corners of the equilateral triangle. Side length எவ்வளவு L. Okay. So இந்த சிஸ்டமோட potential energy நம்ம calculate பண்ணணும். சொன்ன மாதிரி will have how many pairs? 3 pairs. மார்க் பண்ணி பாருங்க. இது ஒரு pair. இதனது second pair. இதனது third pair. So potential energy of the first pair k into q into potential energy termல modulus வராது. அப்படியே values அப்படியே வரும். k into q into minus 2q by L. Potential energy second pair என்னது? k into minus 2q into 3q by L. Potential energy of the third pair k into 3q into q by L. அப்படி நம்ம இந்த மூணு values add பண்ணலாம் அவ்வளவுதான். அதிலிருந்து we are going to get what is the total potential energy of this particular system. இதிலிருந்து we are going to get total potential energy of the system. Check பண்ணி பாருங்க. What is this one? இது என்னது? minus 2 kq square by L. இது என்னது? 2 3 are 6 தானா? minus 6 kq square by L. This is 3 kq square by L. Add பண்ணா minus 2 minus 6 எவ்வளா? minus 8. minus 8 plus 3 minus 5. பாருங்க total potential energy of the system will be what? minus 5 kq square by L. என்ன வரும்? minus 5 kq square by L. இந்த field and forces problem compare பண்ணும்போது இது கொஞ்சம் நமக்கு ஈஸியா தான் வரும். ஏன்னா in this we are not going to have any அந்த வெக்டரோட principles apply அந்த applications கிடையாது. It's a scalar quantity. Okay. பாருங்க this is how we are going to get what is the potential energy of the system. அடுத்த question பாருங்க. So here we have 4 charges. In this we are given the numerical values. முன்னாடி நம்ம சால்வ் பண்றதுல we are not having in numericals. அதல numericals கிடையாது. But இங்க என்ன they are giving us the numerical values. Particularly they are giving us the values. Q1 எவ்வளவு? 1 microcoulombs. Q2 2 microcoulomb. Q3 minus 3 microcoulomb. அந்த மாதிரி Q4 4 microcoulomb. Find electric potential energy of the system of charges. So they are kept at the corners of the square. Diagram oda shape enadi square dana. So 4 charges are there. 4 charges means how many potential energy terms will come? முன்னாடி நம்ம பார்த்திருக்கோம் என்னது? 6 potential energy terms will come. For 4 charges how many potential energy terms will come? 6 potential energy terms will come. Okay. So one நம்ம அந்த expressions எடுத்துட்டு we will have to add all of them. அவ்வளவுதான். பாருங்க first one by one. So we'll just mark it, no? Pair 1, pair 2, pair 3, pair 4. அதுக்கப்புறம் 5th and 6th pairs எப்படி ஃபார்ம் ஆகும் தெரியுமா? இது ஒரு pair Q1 and Q3. அந்த மாதிரி Q4 and Q2 is another pair. இதில் நம்ம ஒன்று போலாம். Like you know, first pair 1. What is the value? K Q1 Q2 by distance எவ்வளவு? 1 meter. So K is what? 9 into 10 power 9. Q1 into Q2. 1 micro, 2 micro. So 1 into 10 power minus 6. 2 into 10 power minus 6. Divide by distance between them எவ்வளவு? 1. which is what? இங்க பாருங்க 9 2s are what? 9 2s are 18, and this is 10 power minus 6 and 10 power minus 6, 10 power minus 12. 10 power minus 12 into 10 power 9, 10 power minus 3 dana, which is what? 18 into 10 power minus 3. idanadi potential energy pair 1. அப்படியே நம்ம மேல எழுதலாம் 18 into 10 power minus 3. அடுத்தது என்ன? for the pair 2 எங்க இருக்கு பாருங்க, Q2 and Q3. Q2 எவ்வளோ? 2 micro, Q3 minus 3 micro. So K, Q2 is a 2 into 10 power minus 3, sorry, minus 6. Q3 எவ்வளோ? minus 3 into 10 power minus 6. Distance is same one only. So what is this one? Minus 54 into 10 power minus 3. 2 3s are 6, 6 9s are 54. Minus varum. So minus 54 into 10 power minus 3. அப்படியே நம்ம எல்லா values மேல எழுதலாம், so that we will be able to easily use them. Okay, so potential energy for the pair 1 is over. அதுக்கப்புறம் pair 2 also we are written. அப்படியே நம்ம ஒண்ணா எழுதி we can just simplify it. Okay, if you get some practice means you will be able to do all of them together. ஒரே ஷாட்ல நீங்க எல்லா எக்ஸ்பிரஷன்ஸ் எழுதிட்டு அதுக்கப்புறம் we can simplify. Okay, potential energy for the third pair என்னன்னா Q3 and Q4 ஓட combination. so என்னது பாருங்க, 9 into 10 power 9, Q3 எவ்வளோ? minus 3 micro, Q4 4 micro. so minus 3 into 10 power minus 6, 4 into 10 power minus 6. இது என்னது பாருங்க, 3 4s are 12, 12 9s are 108, minus 108 into 10 power minus 3. okay, அடுத்தது என்ன? the fourth pair பாருங்க, fourth pair and the Q4 and Q1. fourth pair 9 into 10 power 9, Q4 and Q1. Q4 எவ்வளோ? 4 micro, Q1 is 1 micro. 4 into 10 power minus 6, 1 into 10 power minus 6. distance எவ்வளோ? 1. 9 4s are 36, 36 into 10 power minus 3. okay, so இங்க என்ன இருக்கிற பாருங்க, 18 plus 36 எவ்வளோ? 54, minus 54 plus 54 அப்படியே கேன்சல் ஆயிடும். so நம்ம ஆட் பண்ணும்போது என்ன? we have to add all of them, right? finally, so already pair 1 ஓட potential energy plus pair 2 அந்த மாதிரி pair 4 அந்த values நம்ம ஆட் பண்ணா what are we seeing? they are all simply cancelling. so வெறும் அந்த pair 3 மட்டும் it will be remaining. what is it? minus 108 into 10 power minus 3. ஓகேவா? அதுக்கு அடுத்தது என்ன? we have to look at the pair 5 and pair 6. so இதுக்கு we will just erase everything. we just erase everything. வெறும் அந்த pair 5 and pair 6 மட்டும் நம்ம அப்சர்வ் பண்ணலாம். இதில் என்ன தெரியுமா? the distance between Q1 and Q3, what is it? root 2. எதனால் root 2? because that is the diagonal. அந்த மாதிரி distance between Q4 and Q2 எவ்வளோ? அதையும் root தான், because that will be diameter. so பாருங்க, diameter கிடையாது, diagonal. okay, so the potential energy இது 5 ன்னு சொல்லலாம். for the fifth pair Q1 Q3, Q1 1, Q3 minus 3. so 9 into 10 power 9, 1 in 10 power minus 6, minus 3 into 10 power minus 6 divided by distance எவ்வளோ? root 2. so what is it? this is the minus 27 by root 2 into 10 power minus 3. அதுக்கப்புறம் potential energy for the sixth pair என்னது? Q4 and Q2, 9 into 10 power 9, Q4 and Q2. Q4 எவ்வளோ? 4, Q2 2, 2 in 10 power minus 6, 4 into 10 power minus 6 by root 2. this is what? 2 4s are 8, 8 9s are 72, 72 by root 2 into 10 power minus 3. okay, so இதனது minus 27, 72. so 72 minus 27 எவ்வளோ? that is 45 தானா? 72 minus 27 that is 45. so இந்த ரெண்டு நம்ம ஆட் பண்ணா we are going to get how much? it will be plus 45 by root 2 into 10 power minus 3. இந்த ரெண்டு வேல்யூஸ் நம்ம ஆட் பண்ணா we are going to get what? Plus 45 by root 2 into 10 power minus 3. Okay va? So the sum of these two will be what? Potential energy for the fifth and sixth pairs add panna, we are going to get what? Plus 45 by root 2 into 10 power minus 3. Already namakku enna iruka? Minus 108 into 10 power minus 3. So in the renduthile enna pannala? We can take 9 into 10 power minus 3 அப்படியே நம்ம காமன் எடுக்கலாம். 9 into 10 power minus 3 காமன் எடுத்தா what are we going to get? Here we'll have 5 by root 2. என்னது 5 by root 2. Okay. இங்க என்ன வரும்? Minus 12. So first term la it will be what? 5 by root 2, that will be remaining. Second term la என்னது? Minus 12. So this is what is the total potential energy of the system. என்னது பாருங்க? 9 into 10 power minus 3. அதுக்கு bracketல என்ன? 5 by root 2 minus 12. We can also write it like what? Minus 12 plus 5 by root 2. So that is the total potential energy of that system of charges. Okay. In the மாதிரி questions vanda, what is it going to be tested? It will test our patience. Kandipa ஏன்னா because you'll have to carefully make sure that எங்கேயும் அந்த mistake வராம we should be trying to calculate step by step. அப்போதான் approach easy தான். ஏன்னா இதில் நம்ம அவ்வளோ பெருசாக பண்ணுறது ஒன்றும் கிடையாது. Just we have the potential energy formula அப்படியே substitute பண்ணது தானா? What is it that is there? The formula வச்சு we are just substituting each of the things. அவ்வளோதான். But calculation steps மட்டும் we should be a little bit careful. Okay. So this is how we will have to calculate the potential energy of the system. So system of charges என்ன வச்சுக்கோங்க. Then we will have to calculate whatever the number of pairs. For each pair of charges அதுக்கு ஒரு potential energy term வரும். அவ்வளோதான். அது மட்டும் நமக்கு ஞாபகம் வச்சுக்கணும். Okay. அடுத்த கான்செப்ட் என்ன பாருங்க? Work done in modifying a combination of charges. இப்போ இங்க ஒரு combination of charges இருக்குன்னு வச்சுக்கோங்க. We don't know what is the number. Maybe 3 charges ஆகட்டும், 4 charges or 5 charges. You have combination of charges. அதை நம்ம modify பண்ணா we may move the charges here and there. ஒரு சார்ஜ் எடுத்துட்டு அங்கலேருந்து we are taking it and keeping somewhere else. அப்படி நம்ம modify பண்ணா we are modifying it, means we are doing some external force. Apply பண்ணி we are modifying it, right? So the work energy theorem says the work that is done to modify this will be equal to what? What is the work energy theorem statement? Change in kinetic energy plus change in potential energy, right? Given combination நம்ம modify பண்ணா அதுக்கு what is the work to be done to modify? The work that is required by external force will be equal to what? Change in kinetic energy plus change in potential energy. But நம்ம பார்த்த maximum examples என்ன தெரியுமா? They don't talk about change in kinetic energy. The kinetic energy change பத்தி they will not talk about it. Which means the kinetic energy change we will not consider. Only the potential energy change we will consider because of the change in the positions. அதனால என்ன தெரியுமா? If kinetic energy change is not considered, அதை நம்ம கன்சிடர் பண்ணலன்னா, because assume initially all the charges are at rest. அந்த மாதிரி final arrangementலையும் they are all at rest. Means what? Initial kinetic energy 0, final kinetic energy also 0. அதனால அந்த kinetic energy change concept வராது. Okay. Then what do we have? The work to be done to modify this arrangement of the charges will be equal to what? Simply change in potential energy, which is what? The potential energy of the final arrangement minus potential energy of the initial arrangement. அவ்வளவுதான். So இப்போ ஒரு combination of charges நம்ம modify பண்ணோம்னா அதுக்கு what is the work to be done? Work to be done is what? Change in potential energy of that particular arrangement. இதில் என்ன? We are making an assumption. என்னது? We are not considering any change in the kinetic energy. Okay. So maximum examples நம்ம பார்க்க போறது என்னன்னா, we'll have the charges at rest. Initially also they will be at rest. And the மாதிரி final state also they will be at rest. Okay. That is the reason why we'll have arrangement like this. புரியுதா? So the work to be done to modify the charge arrangement is what? As per the basic work energy theorem, what is it? Change in kinetic energy plus change in potential energy. இதுதான் வரணும். But if you consider that the kinetic energy is not changing or the charges are at rest, which means the kinetic energy change concept will not be there. வெறும் the potential energy change மட்டும் நமக்கு வரும். ஓகேவா? பாருங்க, this is a very important area. Even past yearlyum we got questions on this. The work done in taking a unit positive charge from P to A. பாருங்க, P ல இருந்து we are taking it to point A. ஒரு unit positive charge means what? 1 coulomb. 1 coulomb charge and the point P ல இருந்து we are taking it to point A. What is the work done in taking it from here to there? WA. What is the work to be done? WA. Okay va? And from P to B, P ல இருந்து B இங்க எடுத்துட்டு போறதுக்கு what is the work to be done? WB. Then we have to comment on பாருங்க, what is the relation between WA and WB. We have to comment on what is the relation between WA and WB. So where is the other charge? Engerika? This is where the charge Q is the other charge. Okay, now first நம்ம என்ன தெரியுமா, we will look at moving to A. From P ல இருந்து moving to A, அது நம்ம பார்க்கலாம். first initial potential energy எவ்வளவு? K into Q into 1. ஏன்னா நம்ம கிட்ட இருக்கிறது என்ன? யூனிட் சார்ஜ். K into Q into 1 by R, அதுதான் initial energy. final potential energy எவ்வளவு? K into Q into 1 divided by, இப்போ நம்ம P ல இருந்து A கிட்ட எடுத்துட்டு போனா what is the distance now between the charge Q and our unit charge? இங்க வருது unit charge. What is the distance between them? D தானா? So work to be done in this case is what? WA. அதாவது change in the potential energy. இங்க அந்த kinetic energy பத்தி நம்ம டிஸ்கஸ் பண்றது கிடையாது. So we are assuming that initially the charge is at rest, அந்த மாதிரி final also it is at rest. அதனால the work to be done to move it from P to A will be what? Final energy minus initial energy தானா, which is what? KQ by D minus KQ by R. அது அப்படியே இருக்கட்டும். Then we will look at the second situation. What is it? Moving to B. P ல இருந்து moving to B. அது பாருங்க, இங்க என்னது? initial state same தானா, because we are at the same point. P ல இருந்து நம்ம ஸ்டார்ட் பண்ண போறோம். What is it? K into Q by R. final potential energy எவ்வளவுன்னு பாருங்க. P ல இருந்து we are taking it to B. இப்போ what is the distance of our 1 coulomb charge from the Q? இது என்னது? இதையும் D தானா? What is the distance of the 1 coulomb charge from the Q? It is D only. Means final potential energy is also what? K into Q into 1 by D. KQ by D. So work to be done to take it to B. Adanadi final KQ by D minus initial. Rendu same dana. Work to be done to take it to the point A will be same as work to be done to take it to the point B. Okay, so what is the relation they are asking? They are asking what is the relation between and WA WB. They are asking what is the relation. So correct answer another option C. The WA value will be equal to what? WB. Okay. Another question paranga. 4 equal charges capital Q are placed at the 4 corners of the square. So நம்ம கிட்ட என்ன இருக்கா? There is a square of side length A. Okay va? அதோட 4 corners la we are keeping a charge. ஒரு cornerலையும் we are keeping a charge Q. Okay. The work to be done in removing a minus Q from the center of the square to infinity. So in the center of the square la there is a minus Q charge nu vechukonga. Center of the square la there is a minus Q charge. Okay va? இந்த minus Q charge நம்ம remove பண்ணணும். Remove பண்ணி எங்க எடுத்துட்டு போணும்? We should take it to infinity. Center of the square la irundhu we should take it to அப்படியே infinity கிட்ட எடுத்துட்டு போணும். அதுக்கு they are asking what is the work to be done. இதுல என்ன தெரியுமா? See, totally how many charges are there? நம்ம கிட்ட 5 charges are there. ஏன்னா ஒரு cornerலையும் we are having a charge. அதுக்கப்புறம் central there is a minus Q. Totally how many charges are there? 5 charges. இதுல என்ன தெரியுமா? we are going to get 5 into 4 by 2, n into n minus 1 by 2, totally 10 pairs can be formed, which means what? 10 potential energy terms will come. அதில் எத்தனை potential energy terms will come? 10 will come. பட் என்ன தெரியுமா, அந்த கார்னர்ஸில் இருக்கிற சார்ஜஸ் மூவ் ஆகிறது கிடையாது. வெறும் இந்த சென்டரில் நம்ம வச்சா தெரியுமா, அந்த மைனஸ் கியூ, அது மட்டும் we are taking it to infinity, which means out of these 10 potential energy terms, right, change will happen. எங்க வரும் change? Change will happen only in the potential energy terms involving minus q. எந்தெந்த டேர்ம்ல அந்த மைனஸ் q இன்வால்வ் ஆகுதோ அதுல மட்டும் சேஞ்ச் வரும். ஏன்னா மற்ற சார்ஜஸோட அரேஞ்ச்மெண்ட் நம்ம ஷிஃப்ட் பண்றது கிடையாது. மற்ற சார்ஜஸோட அரேஞ்ச்மெண்ட் as it is, right? ஸோ வெறும் எந்தெந்த டேர்ம்ஸ்ல மைனஸ் q சார்ஜ் வருதோ அந்த வேல்யூஸ் மட்டும் சேஞ்ச் ஆகும். ஸோ இப்போ என்ன தெரியுமா, when we want to find work to be done, when we are disturbing or changing or modifying a charge arrangement, என்ன சொல்லியிருக்கோம், the work to be done will be equal to what? Change in potential energy தானா? Work to be done is what? Change in potential energy. But இதில் change in potential energy ன்னு சொன்னா we should look at only the change happening for the potential energy involving the minus q. Potential energy terms involving minus q. இங்க பாருங்க எத்தனை terms வரும்? Minus q will interact with all the 4, means 4 pairs will involve minus q. 4 pairs will be involving minus q. இப்படிதானா? So இங்க பாருங்க, if the side length is a, what is the diagonal in a square? What is the diagonal? Already நம்ம இதுக்கு முன்னாடியே பார்த்திருக்கோம், √2 times of the side length. Center to corner distance will be half the diagonal. D and so now what is the distance? It will be half the diagonal, which is what? √2a by 2, which is a by √2. Distance from the center to corner will be what? A by √2. இங்க பாருங்க, potential energy of one pair q1 minus q, அந்த ஒரு pair மட்டும் what is the potential energy going to be? பாருங்க, k into q into minus q divide by a by √2. distance எவ்வளவு? அந்த ரெண்டு ரெண்டுல a by √2 தானா? ஸோ இங்க பாருங்க √2 மேலே போயிடும். what is it? minus √2 kq square by a, minus √2 kq square by a. okay, so இது என்னது? potential energy for one term. இங்க பாருங்க, this all the 4 potential energy terms என்னது? identical தானா? all the 4 potential energy terms are what? identical. So the total potential energy involving the minus q charge, total potential energy involving the minus q charge, அது எவ்வளவு வரும்? 4 times of this value. ஒரு பேருக்காக this is the value, right? So we have 4 such pairs, means what? The total potential energy involving minus q. இது நம்ம மிஸ் பண்ணக்கூடாது. we are only considering the terms. எதனால? because only the எந்தெந்த potential energy terms இந்த minus q வருதோ அந்த வேல்யூஸ் மட்டும் சேஞ்ச் ஆகும். remaining potential energy terms will not change. அதனால we are only considering the potential energies involving minus q. so total potential energies involving minus q initially is what? இதோட 4 times, means minus 4 √2 kq square by a. இது நம்ம இங்க ஒண்ணு மாதிரி எழுதலாம், minus 4 √2 k will be what? 1 by 4 pi epsilon naught. The 4 cancel out. what is it? minus √2 q square by pi epsilon naught a. This is the initial potential energy. minus q அங்கலேருந்து எடுத்துட்டு we are taking it to infinity, means what? நம்ம infinity கிட்ட எடுத்துட்டு போனா then the minus q will not be interacting with any of these charges. the minus q நம்ம infinity கிட்ட எடுத்துட்டு போனா there will be no interaction, right? means what? the final potential energy involving minus q will be what? 0. எதனால? because the minus q is going and sitting at infinity, so interaction இருக்காது. so இதுல work to be done will be what? change in potential energy dana, which means what? Final potential energy 0 minus initial potential energy minus root 2 q square by pi epsilon naught into a. Idhula paranga minus minus will become plus. So what is the answer? Root 2 q square by pi epsilon naught into a. So this is the work to be done in moving the minus q from the center of the square up to infinity. So idhula ore oru enna theriyuma, we are looking at only change in the potential energy for the potential energy terms involving minus q. Edhanala because veru minus q oda position mattum is changing, then means what? Other potential energy terms neenga inga parunga, this q and this q, that is also pair, adu apdiye iruka, that pair initially and the value da varum, finally also potential energy will be same, adu change agala. Veru the potential energy terms, 4 of them involving the minus q, initially the value will be something minus root 2, totally enna minus root 2 q square by pi epsilon naught into a, the 4 pairs oda total value. Finally enna minus q apdiye is going to infinity, right? So interaction irukadu. So potential energy of minus q by the pairing with any of the other 4 charges is what? 0. So work to be done is what? Final potential energy minus initial potential energy dana. So finally 0 minus initial value, subtract panna adulande we are getting what is the work to be done. Okay va? So this is how we'll have to approach these questions. Next class we'll try to continue with some more problems on this. Adukapram we'll go and look at the concept of the potential value. So electric potential. So potential energy பத்தி நம்ம எதுக்கு நம்ம டிஸ்கஸ் பண்றது, because இதுல இருந்து தான் அந்த potential electric potential concept வரும். So next class we'll see how we'll define the electric potential by using the potential energy concept. Okay va? So we'll see in the next class. நீங்க practice பண்ணுங்க.